Hey everyone, in machine learning, we talk a lot about predicting the future. But what if the biggest mysteries are actually about understanding what's happening right now? Today, we're going to be data detectives. We're grabbing our magnifying glass and diving into a technique that uncovers clues buried in mountains of data, all without a single instruction.
Think about how we learn, right? You study for a test, you get a grade, you see what you got right or wrong. There's always an answer key. But what if there wasn't one? That's the huge puzzle we're tackling. How on earth can a machine learn anything if there are no right answers to guide it? It sounds kind of impossible, doesn't it? So this is where our investigation really kicks off. In a world with no labels, no signposts. Imagine you're a detective and someone just drops a massive pile of evidence on your desk. No case file, no background, nothing. Your job isn't to solve a known crime. It's to figure out if a crime even happened at all. And that, my friends, is what we call unsupervised learning. You're basically handing a machine a gigantic, messy pile of data and just saying, hey, go figure it out. The data is totally unlabeled. The algorithm's only job is to sift through all that chaos by itself and see if it can spot any hidden patterns or natural groups.
Okay, here's a super simple way to think about it. Imagine someone dumps a giant box of mixed-up buttons in front of you. No instructions. What would you do? Well, you'd probably start sorting them, right? You'd make piles of red ones, blue ones, big ones, small ones. You're creating the categories yourself, just by looking at them. That is exactly what an unsupervised algorithm does.
All right, so if our algorithm is a detective, what kind of tools does it have? How does it actually go about finding clues in all that mess? Well, it turns out it has a couple of key techniques up its sleeve.
So this detective work really comes down to two main approaches. First, you've got clustering. Think of this as finding the natural crowds in your data, grouping similar things together. Then there's association rules. This is all about discovering common habits, like finding out which items are usually bought together.
And believe me, this clustering thing is everywhere. In bioinformatics, it's grouping genes that act alike, which could be the key to understanding diseases. For businesses, it's finding customer groups they never even knew they had. And yeah, even your phone uses it to automatically sort your photos. It's just pattern finding on a huge scale.
And then you have those association rules. The classic example is what they call market basket analysis. An algorithm plows through millions of shopping receipts and finds this little gem. Hey, people who buy chips also tend to buy cold drinks. Nobody told it to look for that connection. It just emerged from the data. And that simple idea is the magic behind so many of the recommendations you see every day.
All right, we've seen the tools. Now let's see them in action. Let's check out some real-world case files where this stuff is making a huge difference. And the impact is massive. Seriously, your bank uses this for fraud detection. It flags a transaction not because it looks like a known scam, but just because it's weird. It doesn't fit your normal pattern. And you see it every time you open Netflix or Spotify. They're using clustering to find other people with tastes like yours to recommend what you should watch or listen to next. And of course, in genetic research, it's helping scientists find connections that were totally invisible before.
Okay, but here's the plot twist. This is where the case gets really tricky. Just because our data detective finds a pattern, how do we know it's a real clue? How do we know it's not just a random coincidence? And this brings us to the most difficult part of the whole thing, figuring out what success even looks like.
I mean, this is the million-dollar question, right? Without that answer key, an algorithm could group all your customers based on the first letter of their last name. Technically, that's a pattern. But is it useful? Not at all. And that's the real danger here. Mistaking a random correlation for a genuine insight can lead you down a totally wrong path. The correctness of a find really comes down to human judgment.
So how do we actually check if these findings are legit? Well, it's got to be a team effort. The data scientist can crunch the numbers and find the clusters, sure, but then you need a domain expert, a biologist, a marketing manager, whoever, to look at it and say, aha, yes, that group makes sense in the real world. It's that combination of human expertise, some clever math checks, and good old intuition that separates a real clue from just noise.
And this is the absolute key takeaway. The algorithm gives you the raw patterns, but it's only when you add human expertise, that real-world context, that the pattern becomes an actual insight. Without that human in the loop, a pattern is often just meaningless.
So with all these challenges, you might be wondering, what's the point? What is unsupervised learning really for? Well, it's not about predicting something specific. It's about something way more exciting. It is a tool for pure, unfiltered discovery. The difference between supervised and unsupervised learning really boils down to the questions you're trying to answer. Supervised learning is for when you know what you're looking for. You have a target. You want to predict an outcome. It answers the questions you already know how to ask. But unsupervised learning, that's for when you don't even know what the right questions are yet. Its whole job is to explore the data and point out what might be interesting.
And really, it all comes down to this single idea. Supervised learning answers questions you already have. Unsupervised learning helps you discover the questions you didn't even know you should be asking. Just think about that for a second. Finding an answer is great, but discovering a brand new important question that nobody's even thought of? Wow, that can change the entire game. It's a true engine for discovery.
And that's really what it means to be a data detective. Unsupervised learning is all about diving headfirst into the chaos of raw data. You're armed with these cool tools and a whole lot of curiosity, looking for those elegant secrets hidden just out of sight. Because the clues, they're always there, just waiting for someone to find them.